Problem number 5 says, you're asked to design a table of 3 meters squared of surface with the form shown below. But the condition to build this table is to use the less material as possible. For this, you're asked to minimize the perimeter. How much does the table measure? This is the figure shown, and the problem is asking us to minimize the perimeter. So we'll need to derivate P, which is equal to the perimeter, and find the minimum value. First, we use the data that we already have from the problem in our mathematical equations. So we know that the area is equal to 3 meters squared. So we know that the area is equal of a square is equal to base times the height, and for a semicircle it would be P times radius squared, and this would be 2 times because they're a semicircle, but you can write it down like this. So then we substitute the value of the area in here, and we change the value of the height by writing that this is 2 times r. And after that, we get the value of b. So b is equal to 3 minus 2 minus p times radius squared over 2r. And we're going to use this value later.
So the first thing you need to do is to isolate b, so you can substitute it afterwards in the p equation. So you have p equation that is pi times d plus 2b. So d can also be expressed as 2 times the radius. So we have p equals pi times 2 times the radius plus 2b. But since we have already isolated b, we can substitute the b in here so that everything is in radius terms. And we have that p equals pi times 2r plus plus 3 minus p r squared over 2r times 2. And if we simplify it, we get this result that is p equals 3 over r minus pi times r plus 2 times pi times r. And we have to derivate this into this one.
From here we need to derivate p, and then this is what we get, and then we need to make the equation equal to 0 in order to get the values of r to get the minimum. We get this, then we simplify, and we get into this point. Then we leave r alone, and we get that the radius is equal to 0.977, and this is just one result, so it is the minimum. And then we need to substitute this in the perimeter equation in order to get the value of p.
Well, in case if we wanted to derivate, the p never gets derivated because it's a constant, and we just multiply the minus 2 times the minus 3, and we get 6r minus 3 because we rest 1. And in order to have r as a positive, we just put it down.